Hello and welcome to today's video. I hope you all are healthy. In today's video, I am going to do a deep dive on AWS Direct Connect. If you want to set up AWS Direct Connect for your organizational workload and want to understand Direct Connect concepts, then you are at the right place. In today's video, I am going to cover all the Direct Connect concepts, how to set up a Direct Connect, what are the resiliency options available for Direct Connect, and any other related concepts. Throughout the course, I will use different screen prints, architectural diagrams, and animations to explain the concepts. If you follow today's video without skipping any content, you should be able to answer any Direct Connect related questions in any AWS certifications, and it should give you a clear understanding about AWS Direct Connect. Before I start, I would like to request you, if you are new to our channel or haven't subscribed yet, please subscribe to our channel and please click on the bell icon to get notification for any new topics. Our goal is to help everyone with premium content without any paid subscription, and your support will motivate us. Without any further delay, let's do a deep dive on AWS Direct Connect. Before I'll start, I would like to cover what and why part. That means what is Direct Connect and why at first place we should use Direct Connect. So let's start with what is Direct Connect. I have taken this definition directly from AWS documentations. As per AWS documentation, they are describing Direct Connect as dedicated network connection to AWS, providing consistent performance and reduced bandwidth cost. So if you observe this definition carefully, they are trying to say this is a dedicated channel or dedicated cable connection between your data center and AWS Direct Connect location. In this definition, I would like to highlight three main points: dedicated, consistent, and reduced. Over this topic, we will try to find out answer or the relevance of these terms. But before moving further, let's see why at first place we need Direct Connect. Now the let's consider this is your on-premise infrastructure where you are hosting a private cloud architecture and you want to extend your data center with AWS cloud, which is public cloud offering. Now if you want to extend your data center with AWS cloud, or if you want a direct connectivity between your on-premise data center with AWS cloud, there are different options you can opt for. The first option is VPN. That means you can set up a VPN connection between your data center and AWS cloud region or AWS public cloud. Now, one thing you should remember, VPN will go over the internet. Now, if I will zoom a little in the VPN technology, we'll see the network traffic from your data center will cross multiple network hops before it will reach to AWS data center or public cloud. As you know, more number of network hops, it will add more delays. So from this diagram, you can understand that your network traffic is fully dependent on the external internet. That means you will not get a consistent performance or consistent bandwidth if you will use VPN connection. Now, if you are using this VPN connection or if you are heavily dependent on that VPN connection for transferring a huge amount of data, let's say you want to transfer data in terms of terabytes every day. In that case, obviously VPN is not a feasible solution because internet speed, number of hops, internet bandwidth, everything will come into picture and will attribute towards your performance. So what is the alternative? The alternative is Direct Connect. Direct Connect is a direct communication between your on-premise data center to AWS Direct Connect location. Now, if I'll try to summarize the Direct Connect purpose, we can understand Direct Connect is a dedicated physical connection. It will have low latency and high bandwidth. Direct Connect will provide secure and private connection. That means it's a dedicated network channel or dedicated cable only for you to use. One point to be remembered here, the traffic is not encrypted, but since it is a private connection, you are secure. We'll discuss that security part and we'll discuss the encryption part later in this session. But for the time being, please remember Direct Connect connection is private and secure, but that is not encrypted. Now the next part is, as I mentioned earlier, there is no internet involved. It's a dedicated channel or it's a dedicated cable between your data center to AWS. That is why it will always provide you consistent network performance. Now let's see how you can set up a Direct Connect connection. One point to be remembered here, in Direct Connect there are actually two aspects. One is the physical connection aspect and the second one is the logical connection aspect. We'll see both the aspect in details. Let's say you have your on-prem data center in some geography. What you have to do? First, you need to find out or you need to set up a router. One point to be remembered here, the router should be BGP enabled. After that, what you will do? You will go to AWS Management Console. If you will go to AWS Management Console, Direct Connect connection, you will get two offering. The first offering is Classic and the second is Connection Wizard. Connection Wizard's offering has been added very recently. First, let's see what does it mean with Connection Wizard. If we'll go, it will give a resiliency toolkit. That means there are different ways you can set up. Either you can set up Direct Connect for a development and test purpose, then you can go for a high resiliency or you can go for a maximum resiliency. So if you see in this diagram, it will give you the entire network topology, how you'd like to set up. Obviously, if you do not have a non-critical workload, you will go for a development and test setup where you will have less resiliency support. That means the connection may have fault or may not be able to resilient across all type of faults, right? But there are options to set up for maximum resiliency. If you are using that resiliency toolkit, as I mentioned, it is added very recently. It will give you the entire network topology and you just have to select what is the region you want to set up your connections. It will have two Direct Connect locations and each locations it will have a redundant connection. We'll cover this part later, so I'd like to request you please hold your doubt for the time being. We'll come to this part later. Now let's move to the Classic part. In Classic part, first you have to select a name and then a location. So now if you see that location, since I am in US East 1, I'll put US East 1 in the location. You have to select your location, AWS region based on your geography. Now if I'll put US East 1, you can see all the Direct Connect locations under US East 1 will be appeared here. Before I'll come here, I would like to show one more point. If you see in this diagram, Direct Connect has mainly two port speed. The first one is 1 Gbps and 10 Gbps. You can select based on your requirement. If you want to transfer huge amount of data, obviously you will opt for a 10 Gbps. One point to be remembered here, this port speed heavily dependent on the selected locations or regions. There are some regions where you can get more options. We'll see that one just in few seconds.
So for the time being, let's enter the location as US is to 1, and since I am close to Virginia, I'll select this Virginia location. Now as I selected the Virginia location, you can see I have three options. Previously it showed me 1 Gbps, 10 Gbps, but as I told earlier, based on the location, you can have more than two options. So here I have 1 Gbps, 10 Gbps and 100 Gbps. One point to be remember, 100 Gbps is not available for all region. Now based on my requirement, I will select 1 Gbps. Then I have to select the service provider who will help me to establish that connection. If I'll click on that search button, here I have different options. Either I can go with AT&T, or I can go with Cloud, or we can go with Comcast. So these are all network or internet provider. You have to select the provider based on your preference. Let's say I will select AT&T here. Now once I'll select and I'll click on the create connection, I will see one direct connect connection will be available in my connection wizard. Once that connection has been created, that means what I have done, I have selected the nearest AWS Direct Connect location which is closest to me. And once you have created that connection in AWS console, you will get a letter of authorization or LOA. You have to take that LOA to that AWS Direct Connect location where you will have a router waiting for you to be connected. Now, if you are fortunate enough, if you have your location or if you have your data center close to that AWS router or AWS Direct Connect location, then it's easy. You can directly connect that. Or else you have to get in touch with some AWS Direct Connect partners. There are many Direct Connect partners who will help you to establish that connection. So based on your geography, based on your data center location, either you will have your own router or Direct Connect partner router. Now the next point is there will be a cross connect or there will be a physical connection between AWS router to customer or your router, and then that connection will be extended to your data center. So you can understand there will be physical cable connection between your customer router and AWS router. So this was the physical connection part. Now we'll see the logical connection part or VLAN. Now let's assume this is AWS global network. So with AWS Direct Connect, you will be able to connect any AWS region except China. For the sake of this example, let's consider I have selected one region, any one region, and for my example, I'll consider I have selected US East 1 or North Virginia location. There I have one AWS VPC. Inside that VPC I have subnet and I have EC2 instance. For simplicity, I have shown only one subnet. Now what you have to do? You have to create one VPG. VPG is virtual private gateway. That virtual private gateway is the landing point to cloud from your Direct Connect tunnel. Every VPC should have a VPG. You can create a VPG in that VPC. So it will be high available. You don't have to really think for high availability of the VPG. Now what you have to do? You have to create an interface, virtual private interface. One point to be remembered here, there are different types of interfaces which I am going to cover. But if you want to establish connection with AWS VPC or any private resources where you are going to establish connection with private IP, you have to use virtual private interface. On the other hand, if you would like to connect with DynamoDB or S3, and if you would like to access DynamoDB or S3 from your on-premise data center with this physical connection and you don't want to go to internet, in that case, since these are public offering and you will connect with public IP address, you need a virtual public interface. So please mind this difference. If you are connecting VPC or any private endpoint or any private service, you have to create a virtual private interface. If you are going to access any public endpoint, AWS public endpoint like DynamoDB, S3, CloudWatch, in that case you have to use public interface. Now you might be asking, is this the two types of interface available in AWS? Let's see that one. The first option we saw, private virtual interface. It used to connect AWS VPC using private IP address. You can use directly or you can use Direct Connect gateway. The second option we saw, public virtual interface, used to access all AWS public services using public IP. There is a third type and we'll come to that part. The third type is transit virtual interface. Transit virtual interface specifically used if you are using transit gateway. And one point to be remembered here, we are connecting transit gateway or transit virtual interface via direct connect gateway. For virtual private interface, we can directly connect AWS router with VPG using virtual private interface, or we can use a direct connect gateway. But for transit virtual interface, the connection should be via direct connect gateway. Now, if you are not familiar with direct connect gateway, let me explain that concept. What is direct connect gateway and why you will use that one? Let's say this was our initial diagram or initial network topology. I have an on-premise data center and I was accessing some AWS region. There I had some VPC and I have used virtual private interface to connect that VPC. But this is not the actual picture when you will work in a production scale. You will have multiple VPCs. Then you will have multiple regions and how you are going to connect. Now let's say in this example, let's say your workload span across multiple regions. Let's say region 1, region 2, and every region you may have multiple VPCs. Then how you are going to connect, right? One point to be remembered here, if you are using virtual private interface, then you have to create separate virtual private interface for each VPG, right? Each virtual private gateway will have a separate virtual interface, which is not a scalable solution in this example. That is why we need a direct connect gateway. You have to remember, if you want to connect multiple VPCs in different region or different account, you should use a direct connect gateway, and now you can use virtual private interface to connect all your AWS VPCs. It could be in different region or it could be in different account. So now you can understand my virtual private gateway, it will connect all the VPCs using direct connect gateway. Now there is one more limitations. Using direct connect gateway, you can connect only 10 VPGs. If you have a requirement of 11 VPC, that means there will be 11 VPG. In that case, you have to configure or you have to provision one more direct connect gateway. One direct connect gateway will support only 10 VPCs or 10 VPGs. Now in terms of traffic flow, any traffic between your VPC or between your region to data center is allowed. So you can understand, using the direct connect gateway, any traffic from VPC 1 or VPC 2 or in region to VPC 2, that will flow to the on-premise data center and vice versa. That means any traffic from on-prem data center will be able to reach these VPCs. But there will be no connectivity between VPCs in the same region or in different region. That means there will be no connectivity between the VPCs. Using this approach, we found two limitations. One limitation is, if you want to connect both your VPCs in the same region or maybe all the VPCs in the same region, it will not support. One Direct Connect gateway will help you to connect up to 10 VPCs. If you have a requirement of 11 VPC, you have to configure another one Direct Connect gateway. In this context, transit gateway will come into picture. So let's say you have two regions and you know in one region you can place a transit gateway and you can connect n number of VPCs. That will connect in hub and spoke model and it will really simplify your network topology. Now you can create peering between two different transit gateway in two regions. In my previous network topology, there was one virtual private gateway in each VPC. I have removed that virtual private gateway and I have connected or I have wired those VPC using a transit gateway. As I told earlier, if you would like to connect transit gateway using your Direct Connect channel, you have to configure a Direct Connect gateway. Now, to connect Direct Connect gateway and transit gateway with AWS router, you have to provision transit virtual interface. You have to remember that one transit virtual interface will help you to connect transit gateway only. You cannot use transit VIP if you want to connect directly VPC without a transit gateway. Now, in terms of traffic flow, traffic between those VPCs in different region to on-prem data center is allowed. Since you are using a transit gateway, you will be able to flow traffic between different VPCs in one region. But if there is no peering connection between the VPCs in two different regions, then the traffic from one region to other region will not flow via Direct Connect gateway. So please mind this traffic flow. You will be able to flow your traffic from any VPC in any region to on-prem data center and vice versa. Since you have used transit gateway, you will be able to connect or you will be able to communicate between the VPCs in the same region. But if you do not have a transit gateway peering between the regions, this traffic flow from one region to other region is not allowed. Hope this clarifies. Now let's compare different interface types we have discussed. The first one is private VIP. As I told earlier, private VIP you can directly connect or you can use a Direct Connect gateway. If you are using a Direct Connect gateway, at max you can connect 10 VPCs with one private VIP. If you are not using Direct Connect gateway, you can connect only one VPC. So you have to remember that use case. If you want to connect more than one VPCs in different region, in different account, you have to use Direct Connect gateway. One Direct Connect gateway will support at max 10 VPCs or 10 VPG. If you have to connect more than 10, you have to configure another one Direct Connect gateway. Now let's move to public VIP. For public VIP, you really don't need any Direct Connect gateway. You can use public VIP to connect any services that is exposed via public URL. And in this connection, you are using public IP address. Services like DynamoDB, S3, Amazon SageMaker, CloudWatch, if you want to access from your on-prem data center using Direct Connect tunnel, you have to create a public VIP. And the third type is transit VIP. In transit VIP, if you want to connect VPCs in two different regions or if you want to connect more than 10 VPCs, in that case, better to use transit gateway. But one point to be remember here, in this architecture topology, you have to consider the cost for transit gateway. One Direct Connect gateway can connect up to 3 transit gateways. But if you want more, you can create peering connections. So now, hope this diagram clarifies the doubt between different interface types available for Direct Connect. Now let's consider or let's discuss the resiliency part. If you remember when I was showing you in AWS console how you can create a Direct Connect connection, there I mentioned the resiliency toolkit There we had three options, if you remember: one for development test, one for high resolution, and the third one is maximum resiliency. We will discuss all that part. Now, when you are creating a direct connect connection, all those previous diagrams, whatever we have discussed, that was not resilient. That means I have one direct connect location, there I have one direct connect or AWS router, and I have a customer data center where I have a customer router. There was only one channel or only one cable from customer data center to AWS Direct Connect location. You can understand this topology is not high resilient because it cannot sustain device failure or location failure, or the cable connection may go out, or there could be cable fault also. Although these routers are high available in nature, but there could be total AWS Direct Connect location can be down, right? This connection is not resilient. Now the next question is, how can we make this connection a resilient connection? The option is this. What you have to do, you can choose a direct connect location. There you can select two cable connections or two direct connect connection. That means if you see this network topology, you will have separate connection terminated or separate device in one location. That means you are hiring two AWS routers for two direct connect connection. In case one router went down, still you will have one cable or direct connect connection to sustain your traffic. In case one channel or one cable went down or there is a cable fault, still you will have one cable to serve your traffic. Now you can understand resiliency against device failure. This particular topology that we are currently discussing, that was mentioned as development and test. Obviously this is for non-critical workload, because you can understand this topology will give you resiliency against device failure. But if the location will go down, in that case you will not have none of the direct connect connection. That means it's not resilient against location failure, and this is, as I mentioned earlier, for non-critical workload. Now let's see the high resiliency option. In high resiliency option, what you are doing, you are selecting two direct connect locations, and in every locations you have a separate direct connect connection. That means what you are doing, you have two single connections to different direct connect location. This will give you resiliency against connectivity failure, that means fiber cut or device failure, as well as resiliency against location failure. If this entire location will go down, then there will be another one location which will still serve the traffic. But one point to be remembered here, let's say you have created these two direct connect location for huge amount of data flow. Let's say daily basis you are sending data in terms of terabytes, or you need a high consistent network in different region. If one will go down, then other connection will have huge amount of load, which may create some performance problem for your application. That is why, although this will support high resiliency option, but still if one link will go down, other link may face tremendous data or tremendous pressure. It can create some performance problem to your application. If your application workload is very critical and require a consistent performance around the clock, then you might opt for maximum resiliency options. So now you can see you have actually 4 direct connect connection. That means separate connections terminate on separate devices in more than one location. So you are not only replicating direct connect connection in one direct connect location, you are replicating the entire location also, right? It will give you maximum resiliency against connectivity failure, fiber cut or device failure, as well as location failure. That is applicable for critical workloads where you demand a huge bandwidth around the clock. Obviously, you can understand this will add a huge amount of cost to your network topology. Now, based on your workload, based on your application nature, you can select any one option. There is another one low cost option if you don't want to configure more than one direct connect connection. As you understand by this time, this is a physical connection or this is a physical cable connection between your customer router to AWS router. But if you are transmitting huge amount of data in terms of terabytes on daily basis, then obviously direct connect will give you a good cost benefit. If you are using VPN, VPN will have connection problem. It will not have consistency. It will go via public internet and you may suffer speed. But direct connect, it will be consistent. It is private. It is secure. Although VPN is encrypted end to end. But now, if your workload is not that much mission critical, or if you don't want to spend on multiple direct connect link, maybe for a temporary basis, or you are fine if your traffic will go via public internet. In that case, what you can do, you can create another one VPN connection. So in any case, if direct connect link will go down, you can use that VPN connection to send traffic or communicate between your on-prem data center to AWS public cloud. You can understand you are using one direct connect or one physical link, another one is VPN. Obviously, this topology will be less costly compared to other three topology we have discussed, where you have discussed multiple resiliency option. That is why I have mentioned this is the low cost option for resiliency. Again, if your requirement demands the traffic should not go to public internet, it should always go or it should always require a consistent performance or a consistent bandwidth, then this is not the architecture for you. But if your topology is very much cost sensitive, in that case you can think for this kind of connection topology. Now, since you are creating multiple direct connect connection, how you can get the benefit? Let's say I have created 4 direct connect connections from 2 different direct connect location, right? So this was the maximum resiliency option where I have 2 direct connect connection from the same locations, right? In that case, there is a concept of link aggregation group. So link aggregation group, it's a logical interface which will use LACP protocol or link aggregation control protocol, which will aggregate multiple connections from a single direct connect location and it will give you a logical high bandwidth network. So let's say you have 2 direct connect location of 1 Gbps using lag. What you can do, you can treat as if it's a 2 Gbps connection. So you can understand you are just summing up the bandwidth of 2 separate connections into one. Lag will treat as a single managed connection. It will aggregate multiple connection capacity. All connections must be dedicated connections with a port speed of 1 Gbps or 10 Gbps or 100 Gbps. We'll see in later slides that there are other options. You can opt for a direct connect connection if you need a lower speed, if you don't want 1 Gbps line. In those cases, you won't be able to aggregate those connections using lag. To use lag, you need minimum 1 Gbps, 10 Gbps and 100 Gbps. And second, you have to remember all those connections should be in one direct connect location. Now, in terms of maximum number of connection you can use for aggregation, if you are using 100 Gbps, then you can have maximum 2 direct connect connection to aggregate in lag. If you are using 1 Gbps or 10 Gbps, in that case, you can have 4 connections or 4 direct connect dedicated connections where you can aggregate those 4 into one. So this point is very vital. You can have maximum 200 Gbps connection or 4 10 Gbps or 1 Gbps connection which you can use to aggregate in lag or link aggregation group. So as I explained, I can create 2 lag 1 for direct connect location 1 and lag 2 for direct connect location 2. Hope this concept is clear to you. Now let's move connection encryption. As I mentioned, if you remember at the first slide, I mentioned it's a secure physical connection, but that is not encrypted. But if you have any compliance or if you have a requirement to encrypt the traffic before sending to AWS, you can encrypt that connection in Direct Connect. And let's see how we can achieve that one. In that case, what we are going to do, we are going to use a VPN connection on top of the Direct Connect. So instead of creating that VPN connection on top of public internet, we will use the Direct Connect connection to create the VPN. To connect VPN, you need virtual public interface. Virtual private interface will not work here. So first, you will set up a virtual public interface. You will extend that connection to customer router, and then you will create a VPN connection from your customer router to your VPG or VPC. In this diagram, this green line represents the VPN connection that will go through your Direct Connect. It will not go via public internet, and as you know, VPN connection is a encrypted connection. The current topology, it will be secured. It's a physical connection and it will be encrypted. So if your network topology demands you need to encrypt your traffic, you can consider to create VPN connection via Direct Connect. Next, we'll see different connection types available for Direct Connect. The first one is dedicated connection. Dedicated connection means what you are doing, you are dedicated connection means you are establishing the connection directly from AWS. In dedicated connection, you have three flavors, either 1 Gbps or 10 Gbps or 100 Gbps for some locations. 100 Gbps is not available in every location. Once you will create a dedicated connection, you will have 50 VIPs. It could be either private or public, and one transit VIP. This point to be remembered, once you have a dedicated connection, you can create maximum of 50 VIPs, either private VIPs or public VIPs, and one transit VIP. That means you will have total 51 virtual interfaces in dedicated connection. The next option is partner hosted connection. As I mentioned earlier, if your network topology demands less bandwidth, let's say if you want to go for 500 Mbps or maybe 100 Mbps or maybe 50 Mbps, in that case you don't really need a 1 Gbps connection. In that case, what you can do, you can approach to AWS partner who has a hosted connection, and you can use that hosted connection and you can select the bandwidth from 50 Mbps to 10 Gbps. You can select 50 Mbps, 100 Mbps, 1 Gbps, whatever you want. But one point to be remembered here, if you are using hosted connection, in that case, you will have only one virtual interface. Either it will be private or public. You will not have more than one private or public VIP. And if you have more than 1 Gbps connection, in that case, you can get an extra transit VIP. So please remember the difference between dedicated connection and partner hosted connection. For dedicated connection, network speed is 1 Gbps or 10 Gbps. For some location, 100 Gbps. Here you will have total 51 VIP. 50 VIP, it could be either all 50 private, all 50 public, or a mix, and one transit VIP. For hosted connection, if your connection speed is more than 1 Gbps, in that case you will have one transit VIP. If you are going for a less than 1 Gbps, you can have only one VIP, that could be either private or public. For more than 1 Gbps, you can have two VIP, one private or one public, and one transit VIP. One point to be remembered, once you have created the connection, you can't change the port speed. Let's say you have created the connection for 50 Mbps and tomorrow you need 100 Mbps line, you won't be able to upgrade. What you have to do, you have to create a new connection. You may have discarded the existing connection and create a new connection, but you won't be able to upgrade the port speed once you have created in hosted connection. There is another one option, hosted virtual interface. If you see in this other two diagram, there was a connection contour. In hosted virtual interface, the connection contour was not available. Here again the port speed, it could be 50 Mbps to 10 Gbps. And one point to be remembered here, the account who owns the VIP is different from the connection owner. Let's say you want to connect your data center with AWS, but you are going for a hosted virtual interface, then virtual interface will be hosted by some other owner. Here you are not owning the virtual interface, and virtual interface will be shared. You can understand it is a shared bandwidth across all the virtual interface on the parent connection. Let's say you are taking the hosted virtual interface from XYZ company, and there are other 10 companies, they are also accessing virtual interfaces. So all those virtual interfaces will share the connection speed. It could be oversubscribed, or you can have the shared bandwidth. You can understand it will have only one VIP, either private or public. There will be no transit VIP. If you want to create transit VIP, then obviously hosted virtual interface is not the option for you. You should go for a hosted connection or dedicated connection. Our team use these links to make their slides. If you want more reading, you can go through these links. With this, I'll conclude today's session. Thank you very much for your time, and I would like to request you, please subscribe our channel and please give us your support with liking this video and sharing this video. And last but not least, please do not forget to provide your feedback as comment to this video. Thank you again for your support. Please subscribe, stay safe and take care.